Collisions happen every day. For example, when you stub your toe, when you slap a fly, or when you're playing pool. When we solve problems involving these collisions, the time interval is so short that external forces like friction and gravity don't really get the chance to do anything. For example, when you punch someone in the face, for the short amount of time that your fist is in contact, you can ignore the friction that comes from your hand rubbing on their face. And you can also ignore the force of gravity pulling your fist down. Because you're only in contact for so short time. Now, what's impulse? Remember Newton's second law in terms of momentum is the net force being applied is the rate that momentum changes, which is this formula right here. Let's multiply both sides by t, and we get this. Change in momentum is equal to force times change in time. The force multiplied by the time interval is equal to impulse. So the impulse is the total change in momentum during this short time interval. On a graph, it would look like this. Let's say this is our very short time interval. This is the time in which the collision happens. And this means force. It'll go up and then it'll go right back down. And the average force during this collision, don't worry, this is all going to make sense soon. The average force would be something like this. And underneath this area, the shaded area, that is your impulse. But this would need advanced math like calculus. So to approximate this changing force, we're going to use an average force. Let's go through a real example. A Kung Fu master, so this is him, he has his Kung Fu beard. He has a brick in front of him. And to prove his Kung Fu strength and his skill, he smashes his head into the brick and it breaks in half. He smashes his head into the brick at 20 meters per second. Let's find the impulse. Force multiplied by time is equal to change in momentum, as we just discussed. Momentum is mass times velocity. So the change in momentum would be mass times the change in velocity, because mass doesn't change. Let's say his head is roughly 5 kilos. That's the object we're working with. Which means that the mass is 5 kilos and the change in velocity is 0 to 20 meters per second. So 20 meters per second. This is equal to 100 kilos times meters per second, which is a weird unit of measurement, but if you remember, that's how momentum is measured. Let's say that the time his head is in contact with the brick is 3 meters per second. That's our time interval. Now, what was the point of finding this? Let's say we wanted to find the force his head is exerting on this brick when he breaks it. Okay, the force formula with momentum is change in momentum over change in time. And we need the time interval. Let's give a rough estimate. Let's say 3 milliseconds. 0.003 seconds, that means. And this is 50,000 newtons, which shows just how good at Kung Fu he is to shatter this brick. So impulse is a pretty abstract concept. But in most physics textbooks and physics courses, you will see impulse denoted with J. For every topic I cover, I like to create a free cheat sheet, and I use them myself as well. So if you want your own with all the formulas you'll ever need in one place, then go sign up in the description.